So in the previous parts, we saw how to develop order service as well as the inventory service. And in the architecture diagram, we saw that our order service will be communicating with the inventory service in a synchronous communication fashion. So in this part, we will see how to establish this synchronous communication using a library called as Spring Cloud Feign. So here I have a small diagram where we are going to discuss more about this synchronous communication. So here we have our order service. So whenever an order service takes a request from the client to place an order, we will implement a logic to call to check if the given product is in stock or not by calling the inventory service, right? So our inventory service is running on port 8082 and we'll be making a HTTP request which requests to the inventory service, and the inventory service will return us a response, and then the order service will go ahead and either place the order and then will throw an error. Here we are first making a request to the inventory service and then waiting for the response from the inventory service, and then we go ahead and process our request, right? So this process is called as synchronous communication. And we also have another part called as asynchronous communication, which we will also discuss in the coming parts, where the order service can send out a request to another service and we don't care about the response, right? We don't wait for the response. We just fire the request and then we go ahead to submit the order. We will discuss a bit more about this asynchronous communication in the coming videos, but for now, this is how the synchronous communication works. We fire a request and we wait for the response, and then once we receive the response, we go ahead with our use case. So to do this synchronous communication, we can use many REST clients in Spring Boot. We can use a REST template, we can use web client, we can also use REST client, which is the latest REST client in Spring Boot 3. But we will use something different. We will use Spring Cloud OpenFeign. So this is a library which is based on the library called as OpenFeign. So this is the documentation of the Spring Cloud OpenFeign library. You can see that this is another library which provides us a declarative form of writing Java HTTP clients, and Spring Cloud OpenFeign acts like a wrapper around OpenFeign and provides us the good integration with Spring Boot. So we'll be using this particular library to make REST calls from our order service to inventory service. So let's go ahead and see how we can implement this in our project. All right, so now I've opened the order service, and now let's add the Spring Cloud OpenFeign library to our pom.xml. So for that, I'm going to open the pom.xml of order service, and here I'm going to take the help of the Spring Initializer website to add the Spring Cloud OpenFeign starter library. So for that, make sure you select the Maven project, and let's add the dependency with the name OpenFeign. If you click on explore, you can find the dependency information for Spring Cloud starter OpenFeign. Just make sure to copy this dependency, go back to the IntelliJ IDEA, and here I'm going to paste the dependency for Spring Cloud starter OpenFeign. So this is not the only thing we need. We also need to also add the parent dependency where all the versions of the Spring Cloud libraries are maintained. So let's go back to start Spring Initializer website. And if you just scroll down, we also have to copy the dependency management section here. Let's paste this just below the dependencies tag and above the build tag. I'm going to press enter and paste this here. We need to also copy the Spring Cloud version. So for that, I'm going to go back to the Spring Initializer website, and I'm going to copy the Spring Cloud.version property and go back to order service. And I'm going to paste this just below the java.version property. Once this is done, let's click on the Maven icon on the top right corner of the IDE to force IntelliJ to download the necessary dependencies. So once this is done, let's verify if OpenFeign is added correctly or not. So for that, I'm going to open the application class, the order service application class, and I'm going to just below the Spring Boot application annotation, I'm going to add another annotation called as enable Feign clients. So this annotation will auto configure the necessary classes to use OpenFeign in our order service project. So the next thing I'm going to do is to create an interface called as inventory client. So for that, I'm going to right click on the root package and I'm going to click on new Java class. Here I'm going to select the interface and I'm going to create this interface inside the package called as client, and I'm going to call this interface as inventory client. So now on top of this inventory client interface, I'm going to add another annotation called as Feign client, and I'm going to name this Feign client with a value as inventory, and I'm going to provide the URL of this Feign client, the root URL as http localhost 8082, because this is the URL where the inventory service is running. So we have to provide the URL of the inventory service. And the next thing we are going to do is we have to define what kind of method this HTTP client is going to call. So this is going to be a get method. So for that, I'm going to add the request mapping annotation and provide the value for the attribute method as request method dot get, and the value of this URL is going to be /API/inventory, right? So if you remember, we have created the endpoint for inventory service in the previous part. So this service is going to return a value of Boolean, and the name of the service is in stock. And we have to provide also the request parameters for this call. So the first request parameter we need to add is going to be of type SKU code, and the second parameter is going to be of type integer, and the name is going to be quantity. So we just need to define this method inside the interface, and Spring and this OpenFeign Feign client will automatically add the necessary implementation to call the inventory service using the get method, right? So this is very somewhat similar to what Spring Data JPA does to implement the logic to write queries automatically, right? So Spring Data JPA abstracts all this logic. All we have to do is extend the JPA repository, and the find all, find one, save methods are all implemented for us out of the box. So similarly, Spring Cloud OpenFeign also provides this functionality where you can just define the kind of HTTP call you want to make, and you need to provide the necessary information like request mapping, what is the corresponding HTTP method, what is the value of the URI path you want to call, and we also have to provide the necessary information like request parameters, path variables, request body, etc. So this is only the get mapping. You can also do the same thing for post, put, or delete in the same way. So the next thing is to call this inventory client from our order service. So let's open the order service class, and in here the first thing I'm going to do is I'm going to inject this inventory client into the order service. So for that, I'm going to write private final inventory client, and inside the place order method, what I'm going to do is I'm going to call the inventory client dot is in stock, and I'm going to provide the two request parameters. The first one is going to be the SKU code, and the second one is the quantity, which is coming from the order request DTO. And let's store the return type in a variable called as is product in stock, and I'm going to add an if condition here. If product is in stock, so what we are going to do is we are going to simply save the order to the database, and if the order is not in stock, I'm going to add an else condition here. I'm going to throw a runtime exception. I'm going to add a message here, product with SKU code. I'm going to add the reference to the SKU code. It's going to be order request dot SKU code is not in stock, right? So let's keep this simple. We're just going to throw this error message, and the next thing I'm going to do is let's test this implementation. So for that, I'm just going to run the application. So our application, order service application, has started successfully. We also need to make sure that the inventory service is also up and running. So let's also open the inventory service, and I'm also going to run the inventory service application. Make sure you run the Docker Compose here, Docker Compose up -d. So here we got an error. It says that the container with name MySQL is already in use by the container of order service. So here in the order service, we are also already using this MySQL with the same name, the container name as MySQL. So what I'm going to do here is I'm going to change the name of this MySQL instance by naming it as inventory service MySQL. Right, so now let's run the docker compose command again, and we get another error. It's saying that the port 3306 is already taken by the existing service. So what I'm going to do is I'm going to change the port to 3316, and let's run the docker compose command one more time. And now the service is starting successfully on the port 3316, but we have to change also the JDBC URL to use the port 3316 but not 3306. Now let's open the inventory service application and run the application now in the debug mode. And now you can see that the application is running successfully on port 8082. And now let's open Postman. And now I'm going to make a call to the submit order endpoint on the URL localhost 8081/API/order. The SKU code is going to be iPhone 15, and I'm going to make a post request. So let's click on send, and you can see that we got a response order placed successfully. And if I place make the quantity as 101, you can see that we are getting an error, a 500 internal server error. Let's go to order service. You can see that we are getting exception with the message product with SKU code iPhone 15 is not in stock. So in this way, we can implement the synchronous communication in our project using Spring Cloud OpenFeign. So till now, we have done the manual testing using Postman. So in the previous part, I showed you how to write integration tests for the product service, and also I gave you assignment to write integration tests for the order service as well as the inventory service. I hope you try to attempt to write the integration test. If not, I have also provided you the link to the blog post where you can copy the integration test and use them. So if I go back to the order service application test, we have the integration test. And now let's try to run this integration test and see if the integration test is running correctly or not. So we can see that the integration test is running fine. So what it is doing is it's actually trying to call the inventory service directly, because if I go to the inventory client interface, we have provided the URL of the inventory service. So now let's go back to the inventory service and try to stop this inventory service. And now let's run the test again. And of course, this test will now fail. You can see that the test failed with the connection refused error. So this is the problem we have to solve now, because our integration tests are directly trying to connect to the external service. But this is not a good idea, because we can't directly connect to the external service using the integration test. It's not a good idea, because if it's a paid API, then you don't want to call this API on again and again, because you have to pay a lot of money unnecessarily. So the better thing to do in this case is we have to mock this interaction to the inventory client, right? So exactly this call, we have to mock it out. We can do that in two ways, right? The first way is using Mockito, a mocking library called Mockito. So what Mockito will do is it will mock out the interaction to this method. So instead of calling directly the method in the inventory client, it will just provide a mock response, and then we can use this mock response to run our tests. And the second option is we can use Wiremock, right? This is a better option, because if we use Mockito, we are just mocking the method, but we are not actually testing HTTP call. We can use Wiremock to actually mock out the API itself, and in this way we can actually test the HTTP interaction. So let me show you with an example with a diagram. So in the real world, what we are doing is our order service is calling the inventory service, which is running on port 8082, right? So what we will do now in the integration test is our order service will call the Wiremock server, and the Wiremock server will stub the call to the inventory service. So we'll provide a stub, and then we'll provide a mock response for the ease in stock API call. All right, so now I hope you understood why we want to use Wiremock to test out the external API communication. So now let's remove this comment from the order service. And now to add Wiremock to our project, what we are going to do is I'm going to open the Spring Initializer website one more time. And here I'm going to add another dependency, and I'm going to search for Wiremock. And if you search for Wiremock, you can see the dependency called contract stub runner. Let's add this dependency because the dependency is coming from a project called as Spring Cloud Starter contract. So this dependency also includes the dependency to run Wiremock server. So I'm going to copy this dependency and I'm going to open order service. I'm going to open the pom.xml file, and here I'm going to paste this dependency. So once the dependency is downloaded, the next thing I'm going to do is I'm going to open the order service application, and I want to auto configure all the Wiremock related classes. So for that, I'm going to add the auto configure Wiremock annotation. And what this will do is, if you go inside this auto configure Wiremock annotation, let's download the sources, and you can see that the description, this is an annotation for test classes that want to start a Wiremock server as part of the Spring application context, right? So this is exactly what we want to do. So for that, we have to provide also the port in which the Wiremock server should run. So what I'm going to do here is I'm going to provide the port option, which is going to be 8080 by default. We don't want to use 8080, but we want to use a random port. So for that, I can just provide the value as 0. So Spring Boot will pick a random port and then it will assign this port to run the Wiremock server. So this is all we need to do to auto configure Wiremock. So I'm going to create a stub for the inventory service. So if I open the diagram one more time, you can see that we have set up a Wiremock, and we also have to set up a stub so that the Wiremock server can answer the request and can answer the request from the order service. So for that, I'm going to go back to the integration test, and here I'm going to create the root package inside the test Java package structure. I'm going to right click and I'm going to create a new class called as inventory client stub, and I'm going to add this inside a package called as stubs, right? So let's add the package name as stubs and create this class, and here I'm going to copy some code to define the stub. So this is the code. I've defined a method called as stub inventory call, and this method is going to take two parameters. The first one is going to be the SKU code, and the second one is the quantity. And here I'm going to first define a stub by using the stub for method, and inside the stub for method I'm going to provide another method called as get, because as we want to make a get call, we are defining a get method, and this get method will be equal to /API/inventory. And apart from that, we also have to provide the request parameters. So this is the request parameters, SKU code and quantity. And whenever Wiremock will receive a request which is matching this URL /API/inventory followed by the request parameters, we are configuring Wiremock to return a response, right? So that's what this will return method will do. Wiremock will return a response with status 200. And we also want to make sure that this response is of type JSON. So that's why we need to add a header with content type as application JSON. And finally, we want to return a response with body as true. So this is how we can create a stub for Wiremock. So now the next thing we are going to do is we have to call this stub inventory call in our application order service application test. So the easiest way to do that is, let's make this void stub inventory call method as static, so that we can just simply refer this method inside the test. So let's go back to the order service application test, and just before the test here, I'm going to make a call to inventory client stub inventory call, and here I have to provide the SKU code value as iPhone_15 and the quantity as 1, right? So all I have to do is, before executing the test, we just have to call this stub inventory call method, and inside this we have configured the stub to return the response as true whenever the URL is equals to API inventory followed by the necessary request parameters, right? So now let's go ahead and run the test and make sure that the inventory service is not running. So let's go back and see that the application is not running. It is stopped. Now let's run the test. And now we can see that we are still getting the connection refused error. This is because if I open the inventory client, we have hard-coded the URL for inventory service as localhost 8082, right? So this is not a really good idea. What we have to do is we have to take out this URL and we have to create a property inside the application.properties. So what I'm going to do is I'm going to create a property called as inventory.url, and I'm going to provide the value of this property as localhost 8082, and I will use this property here instead of using the directly hard coding the value. So in this way, what I can do is I can override this property inside my integration test. So in this way, we can make sure that we don't hard code and use the real URL while running the integration tests. And now I'm going to remove this hard coded value, and I'm going to provide a Spring expression language variable by providing $, and I'm going to provide a curly brace, and inside this I'm going to add the definition of the property inventory.url, right? So in this way, we don't need to hard code the URL. We can externalize the URL configuration to the application.properties. And now what we can do is we can just simply copy this URL property, and let's go inside the resources folder. So we don't have the resources folder here. So we have to create this resources folder in the test under the test folder. So right click and create a new directory, and this directory is going to be resources. IntelliJ is already providing the necessary information to create the resources folder, but let's go ahead and create the resources folder, and I'm going to add a new file here called as application.properties, and I'm going to paste this inventory.url property here, and instead of providing the URL for localhost 8082, I have to provide the URL for Wiremock. One problem we have here is we don't know at what port the Wiremock server is running. So if you open our integration test, you can see that we have defined the port as 0. So we have asked Spring Boot to use a random port. We don't know which port we want to use for our integration test. So in this case, what we can do is we can add one property variable. So I'm just going to remove the 8082 number, and I'm going to first add a Spring expression language variable by providing $ and providing two curly brackets, and inside this curly brackets I'm going to write Wiremock. So it's going to be wiremock.server.port. So this, by adding this particular variable, Spring Boot will automatically inject the port of the Wiremock server into our application.properties. So whenever our application is running, it will automatically dynamically assign the port of Wiremock server to here. So let's go ahead and test if this test is working or not. So I'm just going to run the order service application test. All right, so looks like our test is executing successfully. Let's see what is really happening here. I'm just going to expand this log, and here you can see that we have a log message from Wiremock. It says that request is received, and the request is received, and the received request contains a get method, and it is made to this particular API URL /API/inventory, and the SKU code is iPhone 15 and quantity is 1, and this is the response which is printed by Wiremock, right? It is returning a 200 status and the body as true, and with a header type as application JSON. So Wiremock is returning this response, and now as we have received the response as true, the order is placed successfully, right? So this is the positive case. We can also add a negative case. I'm not going to add the negative case here.